Okay, we're on the air. Good afternoon, or whatever time it is in your place. My name is Bernardus, and today we'll be talking about server and socket programming. Okay, I'm wearing this uniform because all the clothes that I usually wear during recording are being washed. And instead of wearing another like clothes that will be washed again in like tomorrow, so I decided to wear my TKJ uniform so that tomorrow I can use this immediately. This is my TKJ school's uniform, as you can see. And what a coincidence! Today we'll be talking about the server and socket programming. Hit the theme actually. Okay, so without further ado, let's get started. Being tired is already a staple for a high school student anyway, so let's dive deep into it. In Unix and Linux, everything is a file. So throwback to system calls, you should already understand that whether you're talking to a disk, a file, or even your GPU, and even your headset, you use the same lingua franca of system calls: open, read, write, and close, and maybe a map for memory mapping, but that's beside the point. Unix did this, so how does programmer talk to many things remain the same, whether it is a file, driver, and socket. So what is a server? So we know that backend lives in a computer server. Let's debunk this madness. So in my daily to daily conversation, usually when we say the server, it means that the hardware is down. The computer server is down, right? But server is there are two distinct themes. Computer server is a computer that hosts your backend/server. It is the hardware, while server is a program that serves other programs. It is the software that is bind to a certain port, ready to accept requests. So, like, how should I say? They can be called interchangeably. You can call a computer server a server and a backend a server, but it is best that, and I will do in this video and whole section actually, that I will call the computer server, the software server, a server. So next one is socket and file descriptor. So in Unix and Linux, everything is a file, as we learned in system calls. You write to a buffer and the OS translates what is in the buffer to the tuple needed for the socket. Socket is the one FD pointed to. So, okay, this analogy is actually inaccurate. I just like not research. Research is not the best way to do it. Fix my mental model. Yes, mental model. So file descriptor points to a hidden OS managed table called file descriptor table. So you have your file descriptor right here, non-negative integer, and on the other side we have the information stored. So but the most important one is the buffer. The buffer is where we actually write things. So when we say write to this file descriptor of a socket, we just dump data into the buffer. And the socket is like how should I say? A highway, a pipe. Yes, a pipe is like a more accurate interpretation. So dump to this buffer, and socket is the one responsible for sending it back and forth interchangeably. You don't know how, you just put your packet in the buffer and write your address so your network card and socket can send them. Suddenly oscillators make sense to me. So okay. Okay, OC layer. I didn't have the image, did I? Okay. I don't know if this is allowed or not, so I'm just not gonna do it. I want to explain like the OC layer, and the session is the one. If I'm not mistaken, is the 4th layer. I haven't memorized the OC layers to the full completion yet. Actually, hold on. I have my book right here. So this is the OC layer. So 1, 2, 3, 4. Okay. Okay, so let's just skip this for now. Okay, so okay, this is a quick section. So in IP address, which I learned in TKJ, you know that 127.0.0.1 is reserved for callback IP. What is it? When you bind your program to this IP, it means it's bind to localhost and limited to all the programs inside your host. So basically, let's create an analogy of a house. A house has many rooms. They are called ports. Inside each port, your process can be bind into the certain room. So when your server or program process binds to a specific port, and when you program your process to 127.0.0.1, it means that I don't care, but the only one who can access me and enters my room is the one from this house only. So another server inside this house can access me, but nobody from outside. While when you bind to 0000, he will say, I don't care whether you come from the front door, back door, or even the window itself. As long as you want to go to my room, let him in. That's basically it. 127.0.0.1 means the only process that the only one who can access your process through the ports is the one inside the host or PC. 0000 means anyone, whether they're from the network, Ethernet, or even a window, as long as they want to get to my room, let them in. So this is actually my implementation of code. So let's just straight go into code and let me explain them line by line. It is better for me and it is better for my understanding as well. So at first we have the usual main static void main, and we use try with resources. We create a new ServerSocket. We create a process that binds itself. It automatically binds your process to a port. And listen, so to accept communication, you need to do sorter.accept. So ServerSocket, fetching documentation, wow. Why is it so long when I need it, man? Usually it's okay. So this will basically bind your process to this port, and then we are ready to accept a connection. And when a client connects, it will return a socket object. Socket object is basically an object, or should I say, container for your file descriptor. So as I said, that it's like a pipe, a bidirectional communication pipe. A socket is a bidirectional communication pipe. So each connection has their own file descriptor. So now you might ask, how do we not run out of file descriptor? Modern VPS can change their file descriptor from 1024 to 65,535 or even 1,048,576. And it's so small, you don't even need to worry about memory. So what happens right here? We bind our program to the port 8080. We start accepting connection, and once client connects, we print the internet. Not we says that client is connected. We create a new buffered reader. We create a new buffered reader, and we create a new file writer. File writer is like basically how to write to a file, and then we use the print writer. Yes, print writer to print to the socket. So we create a string line, and then we read from the socket line by line. So instead of asking everything in one go, which may be enormous, or going to the CPU for system calls multiple times, we use the goat buffered line. Okay, system out, we print it, and we do it something like that. Oh wait. Okay, let's test this one. We use buffered line so we can grab per line and not spamming CPU with system calls. We use printer writer so we don't need to manually flush, not forget it. Then so that error doesn't break the request. Print error solves the error and silently fail. Accept is blocking, so we immediately serve the first client. So if another client connect, they will be put in a waiting list or ignored. Yes, that's for day one, but let me test this one first. Let's start a terminal and do localhost 8080. Client is connected. I think we should probably start writing something if I'm not mistaken. Echo hello world. Yes, it echoes something back. Yes, a bidirectional communication. That's for day one because I was tired and I'm still is until now. So let's get started into HTTP request in day 2. So I actually woke up at 3 a.m. during Saturday for this one. So yeah, it's a fun. So I'm sorry if I'm lagging behind on this one, because I'm generally I'm tired. So we've heard about the HTTP request and TCP/IP. What are they actually? TCP/IP is the handshake protocol. HTTP is also a protocol, but they are different. TCP/IP or Transmission Control Protocol Internet Protocol okay, is the protocol in which handles how data is sent. It is basically OSI layer, the 4th layer, the transport layer. It primarily is the protocol for breaking and sending or reading data safely. HTTP is the language the browser understands. Now, HTTP is also a protocol, but primarily lives on the 7th layer of the OSI layer, application layer. It is the protocol in which the data will be structured so the browser would understand. So, as we know, the TCP/IP is the protocol in which the data are broken down so it can be sent. Yes, it can be sent menjadi segment. Okay. Meanwhile, HTTP is how the data should be structured. So HTTP request is the word for when we want to create a request to a server. Yes, HTTP request. Can I order an index HTML? So RESTful API was intended to follow HTTP protocol as much as possible, not the other way around. So GET post statuses come from HTTP. HTTP request usually only comes in 3 lines or more if you're doing post and put. The first one is the request line. The server is actually passive. It serves other program, not telling other programs what to do. So this line tells your server what to do. You need to parse this line. It includes a verb, case, post, put, or delete, the thing you want to get, and the HTTP version. The headers. These are like extra information for someone. My house has a blank color fence, or I'm verified, let me in. This is for my mailing post, the mailing post analogy, but it's basically an information like bearer or authorization, something like that you put on the header, like host, localhost 8080. And the last one is the empty line. HTTP protocol dictates that the headers must end with a double new line, \r, \n, \r, \n. This is only for get and delete. For post and put will be discussed later because we need to have content length and content type. So this is what should the HTTP request looks like. This is a simple GET server in Java. Let's paste this one. I'm just gonna paste this one. It starts right. Let me restart the connection. Wait. Oh, I haven't pasted the thing yet. Okay. Let me paste this one. Let me restart the server. Stop and rerun. We cancel this one. Eesh. That was nasty. Okay, we actually got it. The request is still going because the HTTP request hasn't been done yet. But when I do double enter, which will in turn create a double new line or an empty line, the connection revert immediately because the request has been finished. That's a simple GET server in Java. Are things okay down there? So status code is the indication, is your server on fire or not? You might see 200s, 400s, but what are those? So the first one is 200 okay. The analogy is that the server found the file and gives it. 201 is created, 204 means that your requested file is not found. Not found. I did your request, but I don't know what to say. So basically just, I successfully did your task, but I couldn't prove it, so here is 204. 400 is bad request, means you're speaking gibberish, your HTTP request doesn't make sense, and doesn't follow the procedure. So I'm slapping you. That's the analogy. Next one is 401, unauthorized. One word, intruder. You forgot or have wrong key for access, or you're just messing with someone else's data. Forbidden means, boss, this area is restricted even for you. The server recognizes you, but you have no access to the specific file you're searching. Meanwhile, not found means basically the file you want doesn't exist. Method not allowed means your server only handles specific verbs like get, but you ask for delete. Basically asking that the method that isn't allowed. Yes. The next one is internal server error. The quickest way to say it is we're on fire. Generic crash code. So it should be sent before your server burns down. 501 not implemented. We doesn't have that menu yet. When someone asks for head options or unimplemented features and you haven't written code for that, code down yet. 503 means service unavailable. Either your server is too busy or the server is down for maintenance. So to not get the bad request one, you need the content leg and content type. Not fire exactly. Put for post/put and response in get, you need these two so your browser can render things correctly. So as you can see right here, oh wait, the server is still running, right? Let me show you an example. Yes. So how does this website gets rendered? It's because in my HTTP request I sent to the website, I say that okay, everything is good, nothing is on fire, and then I say, oh, I actually sent you an HTML file, so you can render that one, and the size is this much. Remember the empty line we learned about previously? After that empty line starts your, what should I say, your actual data. So HTTP request just basically a quick information, okay, everything is file, but if you want the thing that you're searching for, it starts after the empty line, and this is how big is the data is located on the header. So you look, okay, it is 500 bytes, and then I started taking everything for 500 bytes. Nextly, welcome to my website. Yes, content length is how many bytes or how big it is, but content type is just the type in which the data you sent. So HTML, CSS, JavaScript, PNG, JPEG, GIF, and yada yada. You can see it right here, but I'm not gonna like go through them one by one. So to end day 2, I created a single threaded blocking server. So let's go. As I created I bind this process to port 8080. I initialized a print writer null so it can be accessed during this catch exception. I should actually use try with resources, but what am I doing, man? Oh, no. So I can, as I said, before your server crashes down, you need to send 500 internal server error. So this is why I put the print writer outside, so I can send the error to the server first before crashing down. And then I've manually closed the file descriptor so we doesn't trigger a file descriptor leak. I accept the new connection, and then when the connection is connected, we immediately create a buffer reader to read our client's request. We say that the client is connected, and then we assign the value of a new print writer to the earlier print writer we initialized, and we start reading the line by line. If the first line is null, it is invalid, and therefore we can continue to the next request. But if it is not empty, we parse the first line of request, and then we start taking things seriously. So if they don't request anything, it means they're requesting index HTML, and we take the verb first. Is the verb get, post, put, or delete, in which they will be done in their own specific method, and we create a path to that, like a path which I located inside static right here. Index HTML is located in the static, and since my program starts on the parent folder, this is what I do. We create content length, and then we extract the header one by one. We start reading the header until we get what we needed, content length. If we get content length, we trim it, we split it, so we get how big is the content length actually is. And we switch the method, we pass everything to each method. When we handle get, we put in the file path, we put in the writer, we put in the client socket, basically everything. And if things gone gone south, we send status for 100 byte request. This is basically handle get. If file exists and file is not directory, we check the type first, and then we say, okay, everything is good, here is what you asked. And we copy the file to the output stream. We immediately copy it without putting it in RAM, if I'm not mistaken. Let's see the documentation first. So, my internet is getting worse. Okay. Yeah, basically copy the file as since it's the name. Again, correct me if I'm wrong, okay? Genuinely is stunned right now. I don't know why. Okay, and the post means just create this file and then starts writing. Right. We create a new char body, and then we read the body in which they send. So basically, they send the data, right? We reads it and puts it inside the body, and then we write it to the path and new string, and we say, okay, everything's good. The same with handle put, but we check if the file exists or not. If it existed prior to the method being called, we say okay, we did the request, and 201 for created. Actually, I did a bit of mistake. This should be 201 created because it is successfully created. Handle delete means just delete the file, man. Okay, if I'm not mistaken, I will be using curl. Yes. Okay, I got what I wanted. Let's open it. It opens perfectly as usual. This is the get we're getting. This is the secure server. I need the one where I still type 8080. We post hello tomcat and creates a node.txt, which will be created as you can see right here. Hello tomcat, and then we go further up, and then we put hello world inside. Oh, sorry. We put hello world. Okay, hello world, and then we do the delete one. This is remnants of me coding my secure server yesterday, so forgive me. So yeah, it's deleted immediately. So yeah, this is a not perfect, but a working single threaded. So next section we'll talk about multi-threaded server, SSL, and HTTPS. Okay, let me read first, okay? Okay, so we know that data travels in bytes through the network, but anyone can take it. With tools, anyone can sniff a normal HTTP request and take your data. That's why SSL and TSL, by extension HTTPS, exist. Secure sockets layer is old and technically deprecated, so we'll talk only about transport layer security. Even though it's called SSL certificate, it actually means TSL. So think of TSL like a lock. Everyone know the key or password to lock it, but there is another key or password to unlock it, so that hacker can take the bytes, but it's locked. and they only have the key to lock, which is useless. So this is the first time you visit a website, the browser sends a list of supported encryption algorithms and a random number to the server, like salting. It is actually called number used once, so replay attacks won't happen. Your server picks the strongest algorithm and sends back its public certificate. That public locks that follows the X.509 standard everyone have, alongside the public key, the lock, the domain, who are you, issuer name, who signed the certificate, the validity period, the serial number, and the digital signature. The browser checks the certificate, and as a note, a local host where our server ran isn't owned by anyone, so certification agency can't really know it's you. So basically, when you have a domain, you can verify that you are using TSL by telling them, hey, I already used TSL in my domain. Can you make it HTTP secure? And since localhost means just running on your local host and it isn't a domain owned by you, we can't really do much. The browser checks this, and then the browser creates a pre-master secret and encrypts it with your public key. Only your private key stored in your .p12 in the server can unlock it. Your server unlocks the locked pre-master secret, but so okay, let me explain it in simpler terms. So let's say you need to talk with your friend, but you need a secret encryption key that will encrypt the that will basically make anyone but you two who have the code think you two are speaking gibberish, but you two are actually communicating with each other. Think of it like a language only you two could understand. So let's say this. I put the dictionary, yes. Okay, I put the dictionary of that secret language in a box. I gave the key to lock it to everyone, so everyone can lock it, but not anyone can unlock it. Only your other friend has the key to unlock it. So I sent this through the internet, and everyone sees it, but they cannot physically open it, so it's useless. Your friend, the server, receives it, and then he unlocks the key, and then you two now both have the dictionary. So now you two can start speaking using this pre-master secret dictionary. That's basically it. Again, correct me if I'm wrong, alright? My brain is basically fried right now, so my English is a bit stuttering alongside my logic, so I'm sorry. And as a note, to prevent replay attacks, this process is repeated many times. A new tab, a refresh, a server restart, you name it. So as you can see, in my IntelliJ.idea, we already have this one, and then in this code right here, we implement the TSL and the multi-threading command. So we have a string where our password, about what is our password. So I'm just, since it's self-signed certificate, a password is a password, okay? We make it to a char array. We create a key store. We create a key store to P12 files. And then we read from the key store P12 and load it to the key store. Yes. We load the key into the key store so that when we create an okay, let me think a bit. Alright, let me think a bit. So first of all, we turns our string password to a char array, and then we create a key store with the instance of p12 files, which where our TSL certificate is located, the secret key, and then we read from that p12 files and load the password into the key store. We create a new key manager factory and get the default algorithm. And then with that key manager factory, which will create the key to TSL, we initialize the key store. And then we create an SSL context. And then to connect to the SSL, we connect. Oh, okay. Put the key store. Okay, my brain was too fried, and I'm gonna admit my mistake. Alright, I haven't fully understand what I just wrote. Specifically for this TSL1, I understand that SSL server socket is basically just a secure socket using everything above, but since I don't understand anything above it, it's a nightmare. Alright, so I'm gonna own my mistake this one, and in my next documentation, actually not recording material again, because next week I'm gonna be doing Tomcat, which means I'll be dealing with this monstrosity. Mini Tomcat, alright, not Tomcat, Mini Tomcat. I will go back to this material and explain this one. So my fault on this one, and I'm sorry for it. And then while through, we accept the connection and immediately hands everything to the executor service to start executing things. It starts everything inside the thread, the virtual thread, so it doesn't bother the main thread. And then we immediately force a handshake and we start handling requests. Handling request is basically the rerouting to get post, put, and delete. So that's basically it. It's an HTTPS request. Oh, okay. No, man. I need K after post. Okay, since it's self-signed certificate, URL can't really process it. So that's why we got this error, but it still works nonetheless. I'm gonna do put. This should already work if I'm not mistaken. HTTPS, okay, hello world. And then we're just gonna delete things 443 and make it HTTPS delete. Okay, so that basically marks the end of our today material. I'm sorry that my English is becoming worse. I'm sorry that this material I couldn't explain it very well. I'm gonna take a rest after this, alright? I probably can't write my fanfiction today, so I'm gonna postpone it and just sleep early. So yeah, I'm sorry for the reduce in quality for today's material, and yeah, I'm gonna fix it by next week, I promise. So yeah, for now it's already night by my by my definition. So yeah, I Bernardus signing off. Thank you for